Okay, to graph this parabola, let's first find its vertex. Single most important point on the parabola. The x-coordinate of the vertex is negative b over 2a. In this case, that's negative 6 over 2 times 1, which is negative 6 divided by 2 is negative 3. So the x-coordinate of the vertex is negative 3. And that's also the axis, is the axis of symmetry. That center line through the middle of the parabola. To find the y-coordinate of the vertex, you plug the x-coordinate into the equation, so you get negative 3 squared plus 6 times negative 3 minus 2. That's 9 minus 18 minus 2. That's minus 9 minus 2, or negative 11. So the y-coordinate of the vertex is negative 11. So the vertex of this parabola is the point negative 3 comma negative 11. Now that we know that, let's also find the y-intercept, because that's easy to find. The y-intercept is right here. That's the c term in the quadratic form equation in standard form. So that's the y-intercept at negative 2. So we can graph this parabola now. At least approximately here. The vertex is at negative 3 comma negative 11, so let's go over 3 to the left. Negative 1, negative 2, negative 3. This is the center, the line of symmetry of the parabola and the x-coordinate of the vertex. And negative 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 11. There's our vertex. The y-intercept we found to be negative 2. So here's negative 2 on the y-axis. We get a free point on the opposite side of negative 2. I mean on the opposite side of the center line, which is at negative 3. So that's a distance of 3. So go 3 the other way, which takes you to a point about here. This is negative 6 on the x-axis. Because if there's one point on this side, there's a point on this side, an equal distance on each side. So you get the parabola. It rounds off here a little bit. And there we have, let's see, I can improve this a tiny bit here, but that's a pretty good approximation to the graph of this parabola. One could always improve this by plotting more points, but I wanted to show you how simply you could do this, just plotting the vertex and the y-intercept. Okay, let's try that second parabola now. This is a downward turning parabola. In number 11, a was positive, a happy parabola. This times a is negative, so it's a downward turning parabola. Let's find the vertex first. So the vertex has x-coordinate equal to negative b divided by 2a. In this case, that's negative 7 divided by 2 times negative 2, or 7/4, positive 7/4. To find the y-coordinate of the vertex, you plug this value into the equation for the parabola, so it's negative 2 times 7/4 squared plus 7 times 7/4 plus 5. It's equal to negative 2 times 49/16 plus 49/4 plus 5. Now, let's continue on that one. We've got, this is 2 goes into 16 8 times, so that's negative 49/8. Negative 49/8 plus 49/4. This is 49/8 plus 49/8. One of them cancels, so you end up with 49/8 plus 5. And 5 is equal to 48. So y is actually equal to 89/8. And the vertex then is the point 7/4, comma 89/8. Numerically, 7/4 is about 1.75, is exactly 1.75, and 89/8 is 11.125. So you can see approximately what those are. Meanwhile, the y-intercept, remember that means that x is 0. The y-intercept is given by the constant term here, 5. So let's graph this. We now have enough information to graph this parabola. So here we go. The vertex is at 1.75 and 11.25 up, or 1.25 up. So that's about, let's say this is 1 and this is 2 and this is 3. So 1.75 is about here. That's the center line, the line of symmetry for the parabola. And we have to go up to 11. Let's say this is 11, and a little bit more than 11 is the vertex. And it's opening downwards. The y-intercept is at 5, which is about here, a little less than half. That's the y-intercept. We get a free point on the opposite side. If you go 1.75 plus 1.75, you get 3.5, so here's the other mirror reflection point for that one. And so here we have our parabola. The parabola looks like this.